there! Today's lesson is on work, energy, and power. At the end of the lesson, you should be able to 1. Explain the meaning of work, energy, and power. 2. Explain the meaning of potential energy and kinetic energy. Also, apply the formula power equals to work done over time. Kids, are you ready? Great! Let's begin. Work is said to be done when a force applied to an object moves that object. We can calculate work by multiplying force by the movement of the object. The equation is written as work equals force multiplied force times distance or displacement, which is the same thing as W equals F times D. The SI unit for work is the joule. Kids, let us now look at energy. Energy can be defined as the capacity to do work. It can neither be created nor destroyed, but can be changed into different forms. The different forms of energy include mechanical energy, chemical energy, electrical energy, magnetic energy, light energy, sound energy, and heat energy. The SI unit for energy is joules. Next is power. Power can be defined as the rate at which work is done. The formula for calculating power is power equals work done over time equals force times distance covered over time. The SI unit of power is joules per second, which is termed as watt. Watt can be defined as the power taken to do 1 joule of work in 1 second. We mentioned earlier the various forms of energy. Here we will be looking at potential and kinetic energy. The energy possessed by a body due to its state of rest or motion is called mechanical energy. Mechanical energy is of two forms: potential energy and kinetic energy. Potential energy is the energy possessed by a body by virtue of its position or state, or it can simply be referred to as the energy stored in an object. Kinetic energy is the energy possessed by a body by virtue of its movement, that is, energy in motion. Both are measured by the amount of work done. Kids, let us now look at some calculations involving work done. Example 1. A force of 30 newtons is applied to an object and it moves at 3 meters in the same direction. Calculate the work done on the object. Kids, who can remember what the formula for calculating work done is? The formula is given as work done equals force times distance or displacement. To find the solution, given force equals 30 newtons, distance equals 3 meters, work done, which is unknown, work done equals 30 newtons times 3 meters, which is equals to 90 joules. Therefore, the work done on the object is 90 joules. Example 2. How far must a 5 Newton force pull a 30-gram toy which, if 30 joules of energy is transferred? Use the formula work done equals force times distance or displacement. Given work done equals 30 joules, force equals 5 Newton, distance which is unknown. To find the distance, we need to make the d the subject of the formula from WD equals F times X by dividing both sides by F, that is, WD over F equals F times D over F. F cancels F. Therefore, D equals WD over F, which is equals to D equals 30 joules over 5 Newton, which equals to 6 meters. So the distance that a 5 Newton force will pull a 50-gram toy 30 joules of energy is transferred is 6 meters. Example 3. A force of 200 Newton is used to push a wheelbarrow whose handle makes an angle of 30 degrees with the horizontal over a distance of 50 meters. Calculate the work done. Note, the force F and the distance D are in the same direction of movement or motion. The angle of force, which is 30 degrees to the horizontal direction of the force, has to be converted. Work done is given by F cos D cos 30D. Substituting force equals 200 N and distance equals 50 M. Work done equals 200 N times cos 30 times 50 M. Using either the 4-figure table or calculator, cos 30 is equals to 0.866. Substituting it into equation, we have 30N times 0.866 times 50M, which is equals to 8,660 joules. Therefore, the work done is 8,660 joules. Kids, we've come to the end of today's lesson. We learned about the meaning of work, energy and power, explained the meaning of potential and kinetic energy, and also did some calculations involving work done. See you in the next lesson.